Lesson 12.1a, visual displays of data. And our objectives for today are to understand the basic concepts of data displays, work with frequency distributions, work with group frequency distributions, construct and interpret stem and leaf displays, and work with bar and circle graphs. Okay, basic concepts in statistics. Population includes all of the items of interest. In other words, let's say we're talking about all students in Livingstone College. Okay, that would be population. Whereas a sample includes some of the items in the population. So if we wanted to take a sample, we could say, all right, students, we want to take a sample of Livingstone College math students, but we're going to take a sample of students that are just in this class. So that's the difference between population and sample. A lot of times with sample, it's unmanageable to take a look at an entire population. So if you can take a sample that's large enough, that's a good enough representation of the entire population, then it's a lot more possible to be able to get statistical data from the sample versus the population. Statistics is divided into two main areas: descriptive statistics, and that's where we collect, organize, summarize, and represent data. And inferential statistics, drawing inferences or conclusions about populations based on information from samples. So descriptive statistics gets into organizing, collecting and organizing the actual mechanics, the actual taking the sample itself, whereas inferential statistics, you can basically take that raw data and get some meaningful information out of it. Okay, basic concepts. We're going to look at a problem where we have quantitative data, number of siblings in 10 different families. One family has 3 siblings, one family has 1 family has 2, another one has 1, and so on. 5, 4, 3, 8, 2. So quantitative data takes the number of siblings in 10 different families. And we're talking about quantities, whereas qualitative data, such as we look at the makes of 5 different automobiles, such as Toyota, Ford, Nissan, Chevrolet, Honda, and so on. So qualitative data gets more into looking at when sometimes quantitative data, there's just too much of a difference, like between categories, to where you can't just organize it, so you have to use more of a qualitative form. Like Toyota is totally different than Ford, Nissan, and so on, but you can group all Toyotas together and all Fords together and all Nissans together and so on. Quantitative data can be sorted in mathematical order. So we can take that and sort it out and make that easier to work with. Okay, frequency distribution is when a data set includes many repeated items that can be organized in this distinct. We use X for the first column, distinct values, along with their frequencies. So the frequencies, X would be the type of item, like in this case, number of siblings. X would be 1, 2, 3, 4, and so on. Whereas frequency is you're counting up how much is in each group. And then relative frequency is you take the number in each group divided by the total, and you get a percentage, and that's relative frequency of each distinct item is a fraction or percentage. So that relative frequency is the number in that group over the total, to get, and then multiply that times 100 to get a percentage. Okay, so let's look at a problem where we have 10 students in a math class. We're polled and to the number of siblings on their individual families, construct a frequency distribution relative to the responses below. So we have 10 students, and each student, so the first student had 3 siblings, the next one had 2 siblings, and so on. So we want to construct a frequency distribution. And so the way we do that, put this up at the top, is we make a table. So in this table, we've got a number, and we'll call that X. And we've got frequency, and we'll call that F for frequency, X for the number. And then we have relative frequency. Relative frequency. And that's F over N, which N is the total. Okay, so you have here one sibling, the student has one sibling, the student has 2 siblings, the student has 3, 4, and so 4 is the highest, right? Some students have 4 siblings in them, and that's as high as they go. So we count, we tally them up. Okay, so for one sibling, we've got 1. Okay, for 2 siblings, we got 1, 2, 3. For 3 siblings, we got 1, 2, 3, 4. And for 4 siblings, we've only got 2. So you look at the total, we just add them up, right? 1 and 3 is 4, 4 and 4 is 8, 8 and 2 is 10. So it's a total of 10. So this would be our N. N is used in statistics for total population or total number. Okay? So now, so our frequency is what each category has, the number in each category, number of students that has 1 sibling. 3 students have 2 siblings, 4 students have 3 siblings, and 2 students have 4 siblings. So now we take our frequency, in this case 1 over 10, our total, and so that's 0.1 or 10%. Next is 3 over 10, so that's 30%. 4 over 10, that's 40%. And 2 over 10 is 20%. Okay? So you can see the percentage of students that have 10% of the students have 1 sibling, 30%. So you can look at here what group, or what number of siblings would be the largest. One that has 1 sibling, 2 siblings, 3, or 4. Looking at this frequency distribution. Yeah, 3 siblings, right? Most of them had 3 siblings. All right, good. So now from here, we can put this in a what we call a histogram. Okay, so a histogram is where we take the data from our frequency table and we put it in a graph form called a histogram. And so that we create them as rectangles, and the length represents our frequency. So in our histogram, we have frequency, and we've got the number of siblings. So frequency is the vertical side, number of siblings is the horizontal. And so we've got 0, 1, 2, 3, 4. And siblings, 1, 2, 3, 4. And so we look at the category of 1 sibling, and we're just looking at frequency here is 1. So the category of 1 sibling had a frequency of 1. Category of 2 siblings had 3. So here's 3, so we go up to 3, and we connect each rectangle. So the next one for 3 siblings would be what for frequency? We did 1 for 1 sibling, 3 for 2 siblings, so the next one would be 4, right? So we connect up to 4. And then the last one, 4 siblings, is back down to 2. Okay, and that's our histogram. Okay, so all we did is we took our frequency distribution chart and put it in graph form. Okay, questions there? All right, so frequency is always vertical, and the categories are always horizontal. Okay. Group frequency distributions data sets contain large numbers of items that are often arranged in groups or classes. So here, this is not a group frequency because it was just 1, 2, 3, and 4. But when you have a large number, then you have to group them in the categories. And that's our group frequency distribution. Can we set up a graph display? So again, these are PowerPoints, you have access to them on Blackboard. So if you need to get these steps later, you can. Guidelines for classes of group frequency distribution. Make sure that each data item will fit into one and only one class. In other words, you don't want classes to overlap or repeat. So, for example, you don't want your classes to be like 1 to, let's say, 5, 5 to 10, 10 to 15. You don't want that. You don't want that, because then if you have 5, you don't know which one is going to go in one or the other. So you want to put them to where you have like 0 to 4, 5 to 10. So this would be 0, 0 counts as 1, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. That's 5. 5, 6, 7, 8, 9. Well, that's 10. So then that you have to have them in the same number. So you could do 1 to 5, 6 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to have the same number in each class. Okay? And so try to make all classes the same width, and that's what this is. It's the same number in each class. Make sure that the classes do not overlap. That's what we talked about. You don't want 5 and 5. Use 5 to 12 classes seem to work the best. Too few or too many tend to distort the data. Okay, so let's take a look at a problem. And here we have 20 students selected at random who were asked to estimate the number of hours that had spent studying in the past week. Responses are recorded. And so we have one student studied 15 hours, another one studied 58, another one studied 37, and so on. Tabulate a group frequency distribution and relative frequency distribution and construct a histogram. Okay, so let's rewrite this data. So we have 15, 58, 37, 42, 20, 27, 36, 57, 29, 42, 51, 28, 46, 29, 58, 55, 43, 40, 56, and 36. Okay, so if you added all these together, you get 20. So n equals 20. So we said that we wanted at least 5 categories. We said that we wanted at least 5, between 5 and 20, or 5 and 12 categories. So if we divided this by 5, we would get 5 categories. We would get 4 in each category. So we can say, all right, we can start off here with 10 to 19, and 20 to 29, 30 to 39, 40 to 49, 50 to 59. So you have 5 classes, 1, 2, 3, 4, 5. Yeah. You've got 5 classes, and you've got, so this is a number of hours. And so since 15 is the lowest and 58 is the highest, 15 will fit in the lowest and 58 will fit in the highest. So you know that all your data will fit in all the classes. So now we go ahead and come up with frequency. And that's F. and relative frequency. We can erase this now. And that's F over N. Okay, so we tally all the ones that are from 10, between 10 and 19. So 15 is between 10 and 19, so we'll cross that out. That's 1. So basically we're looking for everything that's in the teens. So that's 15. So we only get 1 there. So now we're looking at items from 20 to 29. So in the 20s. So we look for everything in the 20. Here's 1, 20, 27, that's another one. So we're tallying these up. 29, that's another one. And 28, that's another one. 29. So every 5, we put a bar over it. And that's all. Okay? So now we look at the 30s, 30 to 39. So here's 1, 37, that's 1. 36, that's another. And another 36. So that one's only 3. This is 1, 5, 3 for each frequency. So let's look at the 40s. And notice I tally this, that way I don't miss anything and I don't count something twice. So 42, that's 1. 42, another 42, that's 2. 46, 43, 40, and that's all. So that's 5 again. Okay, and then now we look at 50 to 59. Well, here's 1, 58, 57, 51, 58, 55, 56. So there's 6 of them that studied 50 to 59 hours. So now we do relative frequency, right? So we said that N, the total is 20, right? If we counted all these up, there's 9 and 9 is 18, 20. So N is 20. So now we take 1 over 20. Okay, and that's 5%. 5 over 20, right? And that comes out to be 25%. 3 over 20, and I believe that's 15%. 5 over 20 again is 25%. And 6 over 20 is 30%. Now, you should be able to check these by adding all these up, and they should add up to 100%. Well, 5 and 25 is 30, and 30 and 30 is 60, and 60 and 15, right? 60 and 15 is 75. 75 and 25 is 100, so it checks. So you can check it by adding all these up, and they should add up to 100. Okay, so from there, we want to go ahead and design a histogram. So we take our frequency and our hours, or for each class. Okay? And so we had a frequency of 1, the lowest is 1, but no more than 6. So this would be 0, 1, 2, 3, 4, 5, 6. Okay? And then our number of hours, that's our classes. So the first one's 10 to 19. And the next one's 20 to 29. Okay, 20 to 29. 20 to 29. And the next one's 30 to 39. Next one's 40 to 49. And last 50 to 59. Okay? So now we just look at our frequency. So 10 to 19 was 1. Okay, so we look at, here's our number of hours, 10 to 19. We had 1. Okay, so the next one, 20 to 29, right? What are we going to put for that? Yeah, 5. So we go all the way up here to 5. Put a little squiggly line in it so that we can see the difference in the lines. Okay, 30 to 39. What are we going to put there for frequency? 3, right, good. You got this now. So here's 3. Okay, and then 40 to 49 is 5 again. And 50 to 59 is 6. So you can see that with a picture at a glance, you can see what group of students studied the most hours. Well, 50 to 59, right? Which one studied the least? 10 to 19 hours. Okay, so, and what's interesting is this goes to 20 to 29, then it drops 30 to 39, and then it goes back up. So I would, you know, when you're studying, anybody that would be studying this graph would look at this and think, well, I wonder why this happened. Why did that dip? You know what I mean? And then you could look at that and think, well, was there a problem during that period? You know what I mean? And so you can look at data and see and get some. So right here, all this is considered raw data up here. Doesn't make any sense. So with statistics, you're organizing it and then putting it in a way that you can get a grasp of, a handle on it, and see where there's any issues that could possibly need to be looked at. All right, any questions with that? All right. Okay, so with frequency distribution, we had numbers 10, 20, 30, 40, 50 were lower class limits. So in our histogram here, 10 to 19, 20 to 29, 30 to 39, the lower class limits were the lower numbers in each class, 10, 20, 30, 40, 50. The upper class limits were the end of the class, the higher end of the class, 19, 29, 39, 49, 59. Okay, so the class width, you want the class width to be the same. So it was 10, 10, 10, 10, 10 was the class width, and so on. Okay? All right. Stem and leaf displays. I really like stem and leaf displays because you can take raw data and you can organize it real quickly. So in the stem and leaf display, the tens digit is on the left of the vertical line of the stem, while the corresponding, the units digit or the ones digits are to the right, or the leaf. The stem and leaf display conveys impressions of a histogram. So it's a way that you can organize the data, and you can see from the stem and leaf display graphically what your data looks like. So, for example, if we looked at our data, okay, for, come back here. If we looked at this data here, okay, and we were to put it in a stem and leaf display, this would be the stem leaf. And so you had 1, 2, 3, 4, 5. So this would be the 10s digit, the 20s digit, the 30s digit, the 40s digit, the 50s digit. Because these were from 0 to 10, 0 to 9 in each one, then you could do that. So this way, you're looking at this first one here is 15. So that would be 5. So 1 and 5 is 15. The next one is a 58. So you just put 8. It's like in 58. Next one is a 37. 42. 20. But now you get 27. So you just put a 7 there for 27. 36, you just put a 6. And you get them to line up so that it doesn't get distorted. And then 57, and next is 29. So that would be here, 9. Next is 42. So that's another 2 there. 51. 28. So far the 20s are ahead. 46. So you can see that the 3 digits line up. 29. So this would be a 9 here. 58. 55. 43. 40. And then 56 and 36. So you can see that these line up 1, 2, 3, 4, 5, and 6. So if you look, the stem and leaf display looks very much like the histogram that we just did. And here it is. It looks very much like the histogram, except for it's going horizontally instead of vertically. So you can see the 20 to 29 is larger than the 30. 20s are larger than the 30s. The 40s are larger than the 40s, and the 20s are the same. 50s are the largest, just like on the histogram. Okay? All right, and so that's the stem and leaf display. All right, any questions with that? All right, with bar graphs, bar graphs are different than histograms because with histograms, the bars are connected. And there's classes. So the bars are connected. So where one group ends, the next one continues, and so on. So it's continuous. But with a bar graph, they're separate, like this. They're not connected. And they are not, which is similar to histogram, but the rectangles are usually not touching are arranged, they can either be arranged vertically or horizontally with a bar graph. And so here, this one shows, the graph shows the number of vowels in a particular sentence. One sentence had 2 A's, another one had 7 E's in it, next one had 4 I's and 4 O's and only 1 U. So you can see which vowel is used the most. All right, questions there. Hold on a second. One more thing. Let me go to the circle graph and I'll let y'all go real quick. Circle graphs, you want to take, if you have this problem here, you want to look at, in a school survey, students show that the instructor material answered the questions about how many students would expect to prefer computers from 900 students. So you look at computers and it's 36%, right? So you take 0.36 times 900, okay, and you get your answer, which is 324, okay? So that's one of the problems on the homework, all right? Okay, and so that is today's lesson, all right? So have a good day.